Welcome. Last time I described the second derivative test. It might be easier to follow it if I do that using what's called a flow chart. So it's kind of like a decision tree. I have a function f with continuous second order partial derivative. Calculate its discriminant. Next, we evaluate the discriminant at the critical point x0, y0. If the discriminant is negative, then I have a saddle point. Not a relative extremum, we are done. If the discriminant is 0, generally speaking, very hard to decide what happens. We won't bother doing that. I don't think there are homework problems in the book where you have this situation, and you won't have that on the test either. If the discriminant is positive, then you look at fxx. You can also look at fyy. It turns out they will have the same sign at the point x0, y0. If fxx is negative, then you have a relative maximum. If it's positive, you have a relative minimum. If the discriminant is positive, fxx cannot be 0. Because if fxx is 0, the discriminant is negative of a square, and so it can be 0 or it can be negative, it cannot be positive. So you can just follow along this decision tree and determine what type of relative extremum you have, if any, at a given critical point of a function of two variables.